And what we're looking at today, kind of continuing on from yesterday, is, nope, all right, I'm going to have to move it because that's not going to stay there. There we go. And it works out that the areas of two similar polygons are going to be similar to each other, but we have to do something a little bit different because for perimeter, it's fine. We can just say that the perimeters are proportional. I'm going to go back a few pages. We looked at this here. So if we take the perimeter of one over the perimeter of the other, it's similar to their corresponding sides. But area is a little bit different because when we find an area of a polygon, we're not talking about normal units. We're talking about units what? Because area is normally talked about in not just feet, but in what? Do you all know? Because if you're looking at carpet or laying down paint or looking at flooring, it's not talking square feet because the units are squared. We're multiplying the units together. So when we talk about proportional areas, we can't just say that we're talking about proportional sides. The side lengths have to be squared because area is squared. So when we talk about the proportional sides to it, they have to be squared as well because we have to make it proportional. Now, it also works with volume, proportional volumes, but we wouldn't square for volume. We would actually cube it because volume is in cubic units. Yeah, you're good. Because I would at least, you don't have to write this all out, but I would at least have something now talking about the fact that our units have to be squared because that's going to be important. All right. You're ready to look at an example of this. In the diagram, or in the figure here, ABC, triangle ABC, is similar to triangle DEF. Find the area of DEF. Because this is what we want to know. We want to know the area of these smaller figures. Well, we know the area of the bigger figure is 36. So just like what we did yesterday, we can set this up as a proportionality to fractions. Now, the area that we want to know, we can put it on top over the area that we do know, which is 36. Now we need to set up the other fraction with our side lengths. So what side length would go on top? Mm-hmm. 5 would go on top, 10 would go on bottom. And the reason we do this is because our original starting one that we had the area of the smaller one over the area of the bigger. So when we set up our side lengths, we need the side length of the smaller over the side length of the bigger because these line up. But we have to square the side lengths because area is in square units. So we need both of them to be in square units. Any questions on any of this here so far before we move on? Now we can square this here. We can square 5/10. We can square the 5 and we can square the 10. Well, 5 squared, 5 times 5 is 25. 10 squared would be 100. And for our proportion, we have x over 36 is equal to 25 over 100. Okay. Let's do that on the floor. Now, what do we need to do to both sides to solve for the value of x? We need to multiply both sides by 36. As we multiply both sides by 36, these will simplify out, simplify to 1, leaving us with x is equal to, now we could plug this into the calculator as 25 over 100 times 36, but if we do this by hand, we always multiply with the numerator. So it'd be 25 times 36 divided by 100. 25 times 36 is what we would do first. 0, 3, so 150, 0, 5, which would be 900. And last but not least, we would need to divide these. Well, I hope 900 divided by 100 would be 9. So the area of our smaller figure is 9. And we could put units on it, which would be centimeters squared. So this would be 9 centimeters squared, the area of the smaller figure. Any questions on this here? All right. Let's look at another one. We have this here in the diagram. PQT is similar to RST, and the area of RST is 75 square meters. Find the area of PQT. That's the one we want to know. So we can set up our proportion. So how would we set this up? X over 75 is going to equal what? 10 over 14. We have to square the 10 over 14 because we're dealing with area. Now, if we want to, we can go on and square this here, 10 over 14 squared. Well, 10 squared is 100, and 14 squared, I want to say is 196, but I feel like that's too big. I like that's 13 squared. It is. 13 squared is 169. And then last but not least, we can multiply both sides by 75. Well, these will simplify out, leaving us with x is equal to, well, if we multiplied it, because we could do 75 times 100, that's going to be, I need another 0, 7,500. And if we divide that by 196, I think it might be a little 0.826. Yeah, you did the same thing I did at the start, because we need one more 0. Yeah, I wrote 750 first. 38.26. Would be the area of the other triangle. Questions on any of this here? So this here is, yes?
On the question, does it say the area of RSQ? The area of RSQ is 75.
Yes.
The smaller one.
Yes.
But the area of this bigger one is 38. I got the extra mark too.
Yes. That's for meters.
Wouldn't it have been 14 over 10?
Yes, it should have been. Thank you. That makes more sense. Okay, let me reset. The 75 is correct. So we'd have x over 75 is equal to, it would be 14 over 10 squared. Yes. So the reason it's 14 over 10 and not 10 over 14 like we did the first time is since 75 is on bottom, the side connecting to it would be 10. So they would both be on bottom. So that's where we got it flipped, which changed the answer just a little bit. Now, I'm going to show you this here because when we did this the first time, the steps we did were right, but the numbers were wrong. We don't have to square it first, because what we can do is multiply it both sides by 75 and give us x is equal to 75 times 14 over 10 squared. Now, I have a feeling most of y'all are doing this in the calculator already, because what we can type in is 75 parentheses 14 over 10 close parentheses squared. We can actually type it in like this here and hit enter, and it will actually give us the answer. What is it? 147? So it'll actually give us the answer straight out. So on the last one we had it flipped, which would have given us a little bit different answer. And we get this here. Now, and a good way to check is exactly right, because this side length is 10, this side length is 14. So we should expect this area to be bigger than the original one, because it is proportional. They're increasing everything at the same rate. The only way that this area would be smaller is if the other side lengths were smaller than the other parts of the triangle. But since everything is increasing proportionally, they all need to be bigger. All right, let's go on and do this one here, last one of the day. This is the last problem on the note sheets, and we're going to be done with them after this one here. So these two quadrilaterals are similar. The area of one of them is 84. We want to know the other area of the other one. So here, well, it's kind of a little bit easier to see, but the size of the shape is getting bigger, yes? How much bigger? Because we're going from 7 to what? 21, yes? What times 7 is 21? 3. Okay. So how much bigger do you think the area is going to be? Well, let's see. So we can do x over 84, yes? Is equal to what? 21 over 7. I was real tempting to write 7 over 21, but it's 21 over 7 is, again, the shape is getting bigger. Well, what is 21 over 7 squared? Y'all get 9? And if we multiply both sides by 84, these will cancel, telling us that x is equal to, oops, 756. So it wasn't because 84 times 3 won't give us 756. It's actually multiplied by 9. Yes. Because what did we do with the side lengths? We squared it, yes? Which means, well, 21 over 7 is our scale factor, correct? So really, the area compared to the sides has a scale factor that is squared, because our normal scale factor for comparing the sides is just k. So for comparing areas, it would be k squared. That'd be double it. Not double it, it'd be the square of it. But that's it. That's all we're covering here. I just wanted to finish that up today. And that's all that we're covering here. So at this point here, you can go on